Hello everyone. In this video we're going to be solving a very nice exponential equation from Romania. Romania is known to have an awesome collection of math problems. They're also very successful at international math olympiads, and they do a lot of great competitions at the local and other levels. Anyway, so we have 3 to the power x plus 4 to the power x minus 6 to the power x equals 1, and we are going to be looking for the x values. So to solve this problem, I'm going to use one of my favorite methods, which is substitution. If you said substitution, you guessed it right. So I'll set a equal to 2 to the power x and b equal to 3 to the power x. And notice that 6 to the power x can be written as 2 to the power x times 3 to the power x because the bases are multiplied when the exponents are the same. So from here, we can safely say that 6 to the power x can be written as AB. Great. So let's go ahead and substitute everything into our equation. So 3 to the power x is b, 4 to the power x is what? Okay, I don't know that. So, but, well, 4 is 2 squared, so it's just a squared. Come on, you know that. 6 to the power x is ab, and this is equal to 1. Now, when you look at an equation like this, it kind of looks scary, doesn't it? You have two variables, one of them is quadratic, well, b is multiplied by a, so that looks confusing. But don't worry, this equation is easily solvable, and I can actually present two methods. I don't know if I'm going to do it, but let me just go with the one, and then maybe we can talk about another method too. So, to solve this equation, here's what I'm going to do. I'm going to put the a squared with the -1, and then put a minus sign here, and write it as ab minus b. And there's a reason behind that you'll see in a little bit. Now, a squared minus 1 is difference of two squares, so I can go ahead and factor it. And this one has a common factor of b, which gives us a minus 1. And yay, this is factorable by grouping. So we can take out a minus 1, and then we have a plus 1 minus b. So factoring is very important for solving equations of any kind because that gives us really, pretty much what the roots are. With the sum, you don't get that. So a minus 1, set it equal to 0, you're going to get a solution that means a equals 1. But what is a? Let's go back. A is equal to 2 to the power x. So we have to back substitute, replace a with 2 to the power x equals 1, and you get x equals 0. Easy, right? Any number to the power 0 is 1 except for 0. Okay, let's go ahead and take a look at the other factor because that's going to be much more interesting. A is 2 to the power x. I'm going to bring the 3 to the power x over here, and then plus 1 is equal to 0. Now at this point, here's what we're going to do. We're going to add 3 to the power x to both sides and write it as 2 to the power x plus 1 is equal to 3 to the power x. We could definitely make a separate video on this equation because this is really, really cool. And you've probably seen the most viewed video, which is 5 to the power x minus 3 to the power x equals, what was that? Is that a 16, 4? Anyway, something like that. You get the idea. I think the answer was 2 for that one. So it's very similar to that one. And we're going to solve it by turning it into something manageable. Let's go ahead and divide both sides by the expression with the lowest, highest base, which is 3 to the power x. So that's going to be 2 to the x, 3 to the x, plus 1 over 3 to the x equals 1. Now notice that 1 can be written as 1 to the x power, so we can write this as 2 over 3 to the power x plus 1 over 3 to the power x equals 1. Now this is really cool because on the left-hand side, we have a decreasing function. How do I know that? If you have b to the power x and b is between 0 and 1, then you're going to get a decreasing function. That's what happens. And you can differentiate both sides to see that it's decreasing, right? Because ln b is going to be negative, obviously. So we have a decreasing function being equal to a constant, right? So the left-hand side is decreasing, and this is constant. And what is that supposed to mean? It means that when you look at the graph, and we're going to take a look at the graph, you'll notice that there's going to be a single intersection point. But how do you know the answer? Of course, at this point, you have to kind of guess and check, and it's not hard at all in this case because this problem is contrived, right? Some people like that term. So anyways, it's a competition problem, right? What can I do? So x equals 1 will work because 2/3 plus 1/3 equals 1. I hope you know that. So, and you can also look at it from a different perspective. For example, if x is greater than 1, so we know that x equals 1 is a solution, right? So x equals 1 works. Okay, great. If x is greater than 1, 2/3 to the power x, so something like square 2/3, you're going to get smaller and smaller answers, right? The number is going to get smaller and smaller. Eventually, it's going to approach 0. So if x is greater than 1, then 2/3 to the power x is going to be less than 2/3. And 1/3 to the power x is going to be less than 1/3. And this sum here, which is supposed to be 1, is going to be less than 1. 1 is less than 1. This is nonsense. And for x is less than 1, we get something similar, right? So don't worry about it. We don't get any other solutions from here. So that's pretty much it, right? But let's go ahead and look at it from another perspective, because remember I told you maybe I'll show you a second approach. The second approach is just for solving this equation. So suppose you didn't know this is factorable, and in some cases this equation may not be factorable, right? So let's go ahead and look at it from another perspective, and I'll still have to show you the graph. So this is my equation, and I'd like to write it this way: a squared minus ba plus b minus 1 is equal to 0. And guess what I can do from here? I can go ahead and solve this as a quadratic in a. So from here, using the quadratic formula, a is equal to negative b plus minus the square root of b squared, right? Minus 4ac, which is b minus 1. And that's divided by 2. Great. So now from here, we're going to get b plus minus the square root of b squared minus 4b plus 4. Does that look familiar? That is b minus 2 quantity squared. Therefore, with the plus minus sign, we can write this as b minus 2, but let's keep the parentheses for minus sign. And from here, you're going to get something interesting. If you use the plus sign, you get a equals b plus b minus 2 over 2, which is 2b, or not 2b, sorry, I had to make that joke. You're going to get b minus 1. So what is that supposed to mean? It gives you a equals b minus 1. And you can kind of, plug it in, and you're going to get one of our equations here. Easy, right? Simple. And by using the minus sign, you're going to get a equals b minus b plus 2 divided by 2. And something interesting, you're going to get a equals 1, which is the other solution. So you can also turn it into a quadratic and solve it. Let's go ahead and take a look at the graph now. The graph is also going to give us some ideas. It's not definitely a solution, but it kind of shows you something. So the graph of 3 to the power x plus 4 to the power x minus 6 to the power x intersected with the horizontal line y equals 1, the orange one. And you notice that there are 2 intersection points. I'm not saying that. Desmos is saying that there are 2 intersection points, and those points are exactly given with their coordinates. Therefore, x equals 0 and x equals 1 are the only solutions to this equation. Well, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.